Here in this video, we're going to look at solving quadratic word problems, and the process to this is kind of the same as if you're solving any kind of word problem. If you're not given an equation, one of your first priorities is to write an equation based on the information that's provided, and it can oftentimes be helpful to draw some kind of illustration. And then if you're working with a quadratic application, more times than not always, more times than not, you're trying to find a vertex or a zero. And so that you just try to get an idea of what it is you're actually looking for. And then we can solve by using algebra or graphing depending on the kind of problem. So let's look at this first question. We have the width of a rectangle is the length minus 4 units. And then we're given the area of a rectangle is 12 units. What is the width in units of the rectangle? Well, we would draw us a rectangle here to kind of get an idea of what it is we're looking at. And so what we have is the width of the rectangle is the length minus the 4 units. Doesn't matter what side you call length, but I'm going to call it this bottom side here. And so the width in this case is length minus 4. So I'm going to say L minus 4. So we label two sides. Now we're told that the area is equal to 12. Well, the area of a rectangle should be length times width. Well, we know that we have a length of L and a width of L minus 4, and so that's what we're given. Well, it also tells us that that is equal to 12 units. So let's solve for L, because then if we know L, we can get the width. So we're going to have to multiply out our equation. We'd have L squared minus 4L is equal to 12. Set one side equal to 0, so I'm going to move the 12 over. So I have L squared minus 4L minus 12 is equal to 0. And we're going to solve this by factoring. So this is going to factor. We'd have L and L to make L squared. Multiply together to be negative 12. That adds up to be negative 4 is going to be negative 6 and positive 2. So we'd solve these two expressions for L. So we got L minus 6 is equal to 0, and L plus 2 is equal to 0. And then we solve. So we get a L is equal to 6, and we get a L is equal to negative 2 as possible answers. Now, once you're solving applications, you got to look at the numbers that you have, and we got to figure out if they both make sense or not. Well, we're talking about a rectangle and its length. And because that's what L is. It doesn't make any sense for me to have a length of negative 2. Length has to be either 0 or bigger. So the negative 2 is eliminated as a possible answer, which means the length of this rectangle is 6. And to find the width is going to be 6 minus 4, which gives me a width of 12 units. All right, this next one. 5 times a number is 14 less than the square of that number. Find the negative solution. All right, well, I'm just going to let x be this number, and so we need to think and figure out how to write an equation off of this first expression we have. So 5 times a number, 5x, is 14 less. So usually when you see the word is, you can go ahead and write an equal sign. It's 14 less than the square of that number, so I'm going to square the number x and then take 14 away from it. And so we'd have our expression here. Now that we have an equation, let's solve that expression. And this is a quadratic expression where I have x squared and x to the 1 power. I got to get everything on the same side and make the other side 0. And so we have this. Now we're going to factor that right-hand side, and we're going to solve for values of x. So to make x squared, we'd have x times x. To make negative 14 by multiplying and add together to be negative 5, we're going to have x minus 7 and x plus 2. We're going to set each of the factors equal to 0. And then we would solve for x. So we'd have x minus 7 is equal to 0. X plus 2 is equal to 0. We solve those two little math problems real quick. We get x is equal to 7. And then we minus the 2 here from the other side. And we get x is equal to negative 2. It said, what is the negative solution? Well, that's going to be when x is negative 2. All right, next problem here. So a company is selling widgets. The amount of profit Y made by the company is related to the selling price of each widget, X. Now, using the equation that's given, find the maximum amount of profit the company can make to the nearest dollar. So we need to identify what it is we're looking for. We highlighted the maximum amount of profit, but profit is Y, so I need the max Y number. So what we're going to do is we're going to do this graphically. So we're going to go to Desmos and we're going to type this equation in. All right, so we get our equation typed in. You got to zoom out so that way you can actually see what's happening here. We want to find the maximum. So I'm going to click on the graph. I'm going to go find the maximum. Now we're looking at maximum profit. So that's the Y number. It wants us to round to the nearest dollar, which means that maximum, it would be $838. So we'd say our answer would be $838. All right, next problem. All right, we have a company that's also selling widgets. The amount of profit is Y. That's made by the company. Selling price for each widget is X in this case. We're given an equation, and we want to figure out how much do the widgets need to be sold for to the nearest cent in order for the company to break even. All right, well, break even means that the profit is going to equal 0. So I'm looking for when Y is equal to 0, which are x-intercepts. And so we're trying to solve for x values. So solve for x-intercepts. So we're going to go back to Desmos, type this equation in, and see where it crosses the x-axis at and round it to the nearest cent. All right, so we type in the equation and we look at it, and so we're trying to figure out where does it cross the x-axis at. We want to know how much would the widgets have to be sold for. Well, we actually have two possibilities to break even. We could sell the minimum number, which I say minimum, but I have two options, the 7.865 or the 44.573 number. And so we could sell them for, it said round to the nearest cent, so that's the second decimal place. So $7.87. Or we could also sell them and break even for $44.57. There are two options where we would make no profit. All right, next problem. All right, a rocket is launched from a tower. The height of the rocket in feet is Y. That relates to the amount of time after the launch, X. And so we're given an equation. Use this equation to find the time that the rocket will hit the ground to the nearest 100th of a second. That's two decimal places. So it's going to hit the ground when Y is equal to 0. So we're looking for an x-intercept. So let's go graph this in Desmos to go find our x-intercept. All right, so I have this graphed in Desmos, and what we'll notice is it's a quadratic, so it's going to cross the x-axis two locations. We get an x-intercept of negative 0.386 and 9.037. Now, in context of the problem, we're talking about time here, so x is time, so x has got to be positive. So if I see a negative answer, we don't have time machines that go backwards in time. And in fact, this thing even starts 56 feet off the ground. So I'm going to eliminate the negative one, and my answer here is going to be the positive x value. So what we would say is our answer would be 9 point, so nearest 100th of a second, so two decimal places, 9.07 seconds. All right, last one. A rocket's launched from a tower. The height of the rocket, Y in feet. So height is in feet. X is the number of seconds after launch. Using this equation, find out the time when the rocket will reach its max. So I need to when it's at its max. So when at a max. So we're actually looking, because it's the when, not what is the max, we're looking for the X value here. So we need to graph this, find its max, record its X value, and round it to the nearest 100th of a second. All right, so we type it in. We get the graph here on Desmos. We want to find the max, so we click and find the maximum. It's at this coordinate here. We want to know when did it reach its maximum. Well, that's the X value. We round to the nearest 100th of a second as two decimal places. So this rocket will be at its maximum at approximately 4.59 seconds.